Ryan with Ms.Geek here, and today we've got another update on the BITX40 build, and I'm not sure if this is going to be a single part here with me just talking about this, or if I'm going to combine it with the next part as well, but we'll see how it goes. What you're looking at here is the basic board, sans PA as before. However, I did some testing recently, and I've just been kind of messing with it here and there. And one of the new tools that I got was an oscilloscope. And so what I wanted to do with it is check the signal coming through the bandpass filter here, which I've got kind of moved out of the way here, that normally connects right here, but I needed to be working in this area. And I noticed that the signal going past this is the PA pre-driver, was non-existent. In fact, there was almost no signal going past that. So I thought, well, why could that be? And then I looked at the schematic, and then I looked at what I'd done, and then I realized my error. And that is, I had removed the PA, but I had also removed the PA pre-driver, which is this guy right here. And that would be Q13. And I left Q13, but I didn't realize that this transformer and these capacitors and this resistor were all part of the same thing. I really wasn't, honestly, I wasn't paying attention. And so I just removed too much. So I've spent the last 40 minutes or so just putting this all back together. And then another thing that I had stopped doing was running power to the PA. So now power is running to the PA. Kind of a big deal. So now this rail right here, where this R135, which is this guy right here, he's got power, and that's along this rail right here. So when I go to connect the actual PA, I'll be connecting to that same rail, so I can power the PA itself. Anyway, so that's where we're at right now. My next step is going to be to test this and see if I'm getting gain through this preamp. And now one thing I've noticed that the actual output of the preamp appears to be right here at C134, which is just a decoupling capacitor out to here. But what I noticed is that I don't recall, I'll have to check, but I don't recall if I ever had a the R136 here. I just don't remember seeing R136, although, well, let's see here. Yeah, it was there. So I don't know where R136 went. If I can find it, I'll reinstall it, but I think I'll be okay not reinstalling it. But we'll see. I'll see what kind of output I get. I will be able to measure the output right here, because that's where it went originally. And then there's another decoupling capacitor right here. I think it is. Let's see, that would have been no decoupling capacitor. I'm wrong about that. So yeah, R136 would have varied the input going into the PA, and I just haven't got that. So if I need it, I'll install it. Otherwise, I'm not going to worry about it.
2 hours later.
I spent the last hour and a half or so trying to figure out why on earth the preamplifier wasn't working. And so what I've got here, I've got my oscilloscope probe going, grounded out here, and then I've just got a little bit of a nub coming up here that is enough to latch onto to check the output. And I've got the output going into a QRP Labs 50 ohm dummy load. And so to really test this, I was checking with the oscilloscope, and the first thing I noticed, and by the way, I don't know that I could have figured this out without an oscilloscope, frankly. I'm really beginning to understand how much I needed one. I could have done this without it just by replacing a bunch of parts, but I really wouldn't have understood why it worked. So basically what I found was that this decoupling capacitor here was bad. The one I installed was bad, and so the signal would come in here, but there'd be nothing on the other side. So I replaced that, and that started working. But still, there was nothing else coming out of here. And I checked all the voltages, everything was fine. And so I went ahead and replaced the 2N3904 with a 2N2222 No particular reason I picked a 2222, except that I bought a bag of 100 of them, so I know I have lots of them. And now I'm getting results. I'm actually getting output from the PA, or from the preamp. And I've got to figure out how many volts that is, but let me reposition my camera here and I'll show you what it's doing on the oscilloscope. Okay, so I've got the oscilloscope set up. It's currently at 0.1 volts per division, and it's on its lowest 0.1 nanoseconds per division. And when I key up, I'm now getting a waveform. So just blowing into the mic there. Do, oh, oh. So what I'm going to do is I'm going to crank this up a bit. Oh, oh. And that is getting to right, oh, there. So that's, oh, right there. So that's 1, 2, 3, 4, 6, 7, 8, 9 times 20 millivolts. So that's 180 millivolts, I think. And so let's do some quick math. And I'm not good at the math part, so I'm going to Google it. There's a site that has a calculator online, and I'm going to use it. The website I'm going to use is pasternak.com, and it's got a calculator here. So I'm going to say 180 millivolts to milliwatts. 0.65 milliwatts, which doesn't seem like a lot. So maybe you guys can help me out and tell me if I'm doing it wrong. Somebody can check my work. I can definitely use the assistance. If it's only 0.65 milliwatts, that's way too little. I need 25 milliwatts to drive QRP Labs PA. So maybe another pre-driver. I don't really know. All right, I realized after I made the video that I did the calculation wrong. What I was looking at was about 4 millivolts total, not 2 millivolts. So I did some testing right after I shot that, and it was about 4 millivolts. So I'm going to say 4 millivolts, which is 3.2 milliwatts, which is about 20 milliwatts less than what I need. So still looking for suggestions on how to resolve that. And of course, I'm using the pre-driver on the BITX40. Here's the schematic. And it's got not a whole lot going in and very little coming out. So anyway, thanks for watching. I sure do appreciate it, and I'll look forward to your suggestions. 73.